For this lesson, we'll be taking on fractional indices. It's still on the numerical processes, but these are indices with fractional powers. So let's move right ahead and see what we have. The first one, we'll do a rule for solving fractional indices. And then we have simplification of some examples. Then we'll give you the opportunity to also try out some of your own. The objectives will be, of course, the general law for simplifying fractional indices, solving some of the examples, and then the test. You must obtain an 80% pass mark or above to be able to move over to the next lesson, so that we just understand and fully understand this lesson. So let's move right ahead. There are two types of fractional indices, broadly speaking. The one with a 1 over a denominator, and the one with two variables or two values on the top and the bottom part of the fraction. So let's take on the one with the one part of the fraction first. What we get is, the law states that to find to simplify this value, you're going to have the variable x to the root of a, and that's it. So I'll give an example. If we're to have 8 raised to the power 1 over 3, that will simply be 3 or 8 to the cube of to the root of 3, which is going to be the cube of 8. The cube of 8 is 2. That's because 2 times 2 times 2 is equals to 8. Now that's the first law, or the first type of fractional indices. The second type, states that once you have something like that, you still have b, or the variable x to the root of b, and then we're going to raise x, the variable, to the power of a, or it's still going to be the same thing as having x to the root of b and raise everything to a, to the power of a. I hope that's clear. So that's also in a way means if you have 8 raised to the power 2 over 3, that will be equal to the cube root of 8 raised to the power 2. The cube root of 8 is 2 raised to the power 2 will be 4. That's an example. Let's move to the next slide. Now we want to try to represent the square root of x, so you would also see what we're talking about. And that also goes ahead to prove what we did in the previous lesson. So let's assume x is equal to x raised to the power p. And we know that the root of x times the root of x is equals to x. And x is equal to x raised to the power 1. So having that, the cube of x is equal to x raised to the power p, then we have x raised to the power p times x raised to the power p will also be equal to x, which is also equal to x raised to the power 2p. That's because from the first law of indices, this p plus that p will give you 2p. Now that we have a common variable within this and that, what we then do is equate them together. So 2p, x raised to the power 2p will be equal to x raised to the power 1. And by the way, for any value 2 or any variable x like that, will always be equal to x raised to the power 1. So 2 is equal to 2 raised to the power 1, 5 is equal to 5 raised to the power 1. They're all going to be the same thing, and that's why we have that here. Okay, let's move right ahead. So since we have the common variable here, x, then we can equate the powers together. So 2p will be equals to 1, and therefore p is equals to 1 over 2. So that means that the root of x is equal to x raised to the power 1 over 2. And if you recall from our previous slide, we have it in such a way that x raised to the power 1 over a is equals to a into the root of x. So that means for x raised to the power 1 over 2, that will be equal to 2, or the root of x, which is still the same thing like this. Okay, let's move to the next slide. Now we're going to be trying out some, or applying the rules that we did previously to some real life problems. And let's see how that goes as we move on. So for the first one, 9 raised to the power 1 over 2. That will be, if you recall, x raised to the power 1 over a will be a, the root of x to a. And then so for 9 raised to the power 1 over 2, that will be the root of 9, which is the same thing as doing that. It's going to be 3, because 3 times 3 is 9. Then we have the second one, also from our rule, which also applies, where x raised to the power 1 over a will be root of x to a. And then we're going to have 27 raised to the power 1 over 3 will be the cube of 27, which is equal to 3. That's because 3 times 3 is 9 times another 3 is going to be 27. So that's our answer here. Now let's move to the next slide. Okay, so we're going to do fractional indices with fractional variables. Let's see how that goes. So for that, you're going to have same rule applies for the second example, which is x raised to the power a over b will be equal to b root of x to b all raised to the power of a. So to apply that directly, what we have is roots to the fourth root of 16 over 81 all raised to the power of 3, and that will be 16 will be 2 times 2 times 2 times 2, and then 3 times 3 times 3 times 3 will be 81. So we're going to just go ahead and pick the first one. So that will be 2 over 3 all raised to the power of 3. That's after we're going to solve. The idea is to solve this first and then take it to the power of 3. And then what we then have when we raise this to 3 is 2 times 2 times 2 times 2, which is 8, over 3 raised to the power of 3, which is 27. And that goes our answer. I hope that was pretty easy to solve. Let's move to the next one. Oh, okay. Now we have a negative power and still fractional. If you recall from our last law of indices, so we have x raised to the power minus a will be 1 over x raised to the power of a. Okay? And so therefore, we're going to bring this down here and say that's going to be 1 raised to the power 12 over 75 of raised to the power 1 over 2. And because you have 1 from fraction, 1 raised to the power a over b will be b over a. So applying that here, we're going to have 75 over 12 raised to the power of minus 2, or raised to the power of half, if you do recall. And then that will be the root of 75 over 12. And that's our answer. Let's move right ahead to the next one. So we have a complex combination of variables and a value. And what we'll do is to solve them individually. So we cut this into this, we solve this, and then we solve that. So we'll find the root of all of this. What we can also do is, for the first one, you have your long bracket here. For the first one, you have 16 over 4, solving it internally, and that will be 4. And then x over 2, if you recall from our first law of indices, that states a raised to the power of x raised to the power of a divided by x raised to the power of b will be x raised to the power of a minus b. And also that's for the second law, sorry. And the first one states x raised to the power of b times x, or x raised to the power of a times x raised to the power of b will be x raised to the power of a plus b. So that's law 2 and law 1, if you do recall. So applying these laws here, so x raised to the power of 4 minus divided by x raised to the power of 2 will be x raised to the power of 4 minus 2, and y raised to the power of minus 5, because of this, divided minus 5, which is the lower one. And to simplify this further, you're going to have 4 times x raised to the power of 2 times minus 5 will be minus 5 plus 5, which is 0. So that will be times y raised to the power 0. Now, from our third law of indices, it states x raised any variable raised to the power of 0 will be 1, as long as that variable is not equal to 1. Okay, so we'll go ahead and, or that variable is not equal to 0, sorry. So we'll go ahead and follow up on that one. And that will be root of 4, and then this is 1. So x2 times 1, which is 4x squared. And then that will be equal to 2x. And then this is our final answer. Thank you, and let's proceed to the next slide. Now we're going to try and solve some more. And what we'll do here is to find x for the values, or for the problems that we have. What you need to note is that to be able to find the variable x, we need the variables, we need the values to be equal on each side. So if you're going to find the variable x and x is on the power side, then we'll try to equate this to be the same, so that then x is now equal to what the power here is. I'll give you an example just to try this out. So you have 4x, and then how do we make this 4 so that 4 to the power of something will now be what x is? So for this one, the square root of 16 is going to be 4. So that's 4 raised to the power of 2. So now that we have this as the same value, then we can denote that the value x is equal to 2. Was that very clear? Now let's try another one. For x raised to the power of minus 4, and then that's equal to 3. Now the idea is, how can we equate or give 3 a power of 1 over 4, or put a value here to the power of minus 1 over 4, so that then that becomes what x is when we have the value left. So we have x raised to the power of 1 over 4 will be, so to take this to this other side, that will be multiplying 3 in 4 places, right? Because this is equal to, this is the same thing as doing, we're finding the 4th root of the variable x. If you recall from our first example of fractional indices, that states, let's go ahead and clean that to make it clearer. That states x raised to the power 1 over a will be equal to x to the root of a. And then, so that's why we have 4 here. So what can we do on this side that equates to 3? And then that will be, in another sense, 3 times 3 times 3 times 3, normal equation. And then the value of that, which is 81. So that's 81. That's because if the 4th root of 81 will be 3. So now that we have the structure the same, that means x here is equal to 81. So the value, or the result, will be x is is equal to 81. I hope that was very clear. Now we'll give you opportunities, or we'll give you an opportunity to answer your own question. Thank you very much.